Good morning, guys. I hope everybody's doing well. Um, and I also hope that this first week of remote learning is running smoothly for you. We just started with reviewing factoring quadratic expressions. And now the goal for the next week is to start with polynomial functions, and in particular this unit is about performing operation with polynomial expressions, and also we are going to be able to solve a polynomial equation by factoring, and eventually, if time allows, we are going to talk about graphing polynomial functions. So the goal for today in this short lecture is to add, subtract polynomial expressions, and we're also going to give the definition of polynomial function. So let's start from the definition. A polynomial function is a function that can be expressed as f of x equal to an, which is a real number, x to the power of n, plus an minus 1, x to the power of n minus 1, plus an minus 2, x to the power of n minus 2, plus, and then we're going to have an a1, if we follow this pattern, x to the power of 1, which can be written just as x, and then plus a0, x to the power of 0, but x to the power of 0 is equal to 1, so we can just stop at a0. Now this definition looks very abstract, okay, but we should be already familiar with the polynomial function. We have seen polynomial function. In fact, we have seen already linear polynomial function, and we have seen already quadratic polynomial function. So anytime we solve a linear equation, for example, we are solving a polynomial function of a polynomial equation of degree 1, and anytime we solve a quadratic equation, we are dealing with a polynomial expression of degree 2. So we have already seen. This is more a general definition of a polynomial, which the degree can be any whole number, so not necessarily 1 or 2, but it can be 3, 4, and so on, any number also greater than 2. Now we need to specify in this definition that the coefficient an minus 1, and so on till a0 are real numbers. They must be real number. And then and then n, which is the integer you see at the exponent, must be a positive integer, okay? So n must be a whole number, okay? So let me show you some example as a non-example of polynomial function. So an example may be 3x squared minus 1. So let's put an f of x here. So f of x equals 3x squared minus 1. And here I put a non-example. A non-example may be 3x to the power of negative 3 plus x squared minus 1. So what's the difference between these between the left hand side and the right hand side? So here on the left hand side I have a polynomial function because the coefficient that are 3 and negative 1, so these two numbers are real numbers. Now that's true also for the right hand side. I have a 3, I have a 1 in front of x squared, right? And then I have a negative 1. So these are also real numbers. The problem is the exponents. If you look on the left hand side, the exponent on the left hand side is the highest exponent, at least here is 2, but here we have a negative 3. We cannot have a negative exponent. So when I say that n must be a whole number, it means something that must be positive, okay? So it cannot be negative. We can have a 0 as exponent, but we cannot have a negative exponent like in this case, okay? So if you look on the again on the right hand side, we have x to the power of negative 3, so this is not a polynomial function, okay? And let me show you one additional example. So here I have f of x equal to 2x to the power of 5 minus 2i x plus 1. I'm sorry, I want to make it here on the left hand side the polynomial function, so I'm going to write plus 2x plus 1, and then here on the right hand side for the non-example I have a 2x to the power of 5 minus 2ix plus 1. Okay, so here on the right hand side so all the requirements for a polynomial function are satisfied. We have a real coefficient, we have exponents that are whole numbers, so we're good with that. But if you look on the left hand side, there is a 2i in front of x, so this 2i, this negative 2i, is an imaginary number, it's not a real number, and therefore this on the right hand side is not a polynomial function, okay? So this is just to give you an idea of what's a polynomial function. Now let's see how to add and subtract a polynomial function. And the strategy we're going to use is actually pretty simple, because the only thing we need to do is combine like terms. So let me show you an example. Imagine we have a triangular road sign. So I just make a triangle. And what we want to do, we have the length of those sides. So imagine this is 2x cubed plus 1. X can be any number. And here I have 5x plus 2. And then this side at the bottom is x cubed plus 5x squared minus x minus 2. And what we want to do is find the perimeter, okay? Find the perimeter of this road sign. How are we going to find the perimeter of this road sign? Well, by definition, perimeter means add up the length of the three sides, so we just need to add up the first side, 2x cubed plus 1, with 5x plus 2, and then plus the third side, which is x cubed plus 5x squared minus x minus 2. And notice that since we have a plus in between those parentheses, we can actually drop those parentheses so they have no effect on simplifying this polynomial expression. So plus 5x plus 2 plus x cubed plus 5x squared minus x minus 2. So we can just remove those parentheses, and now we're going to combine like terms. So we're going to start, for example, from the highest degree terms. And then notice that the highest degree term is an x cubed, so I'm going to combine 2x cubed with x cubed, and this can be combined to 3x cubed. And then let's take a look at the x squared term. We only have a 5x squared by itself, so I'm going to keep it. And then for the x's, I have a 5x, I have a negative x, so 5x minus 1x is going to add up to 4x. And notice finally that I have a, if you look at the coefficient, if you look at the numbers, we have a 1, we have a 2, and we have a negative 2. So 1 plus 2 is 3, and 3 minus 2 is 1. So we can just have plus 1. Okay? So this is the simplified perimeter for this triangle. Okay? And these represent a polynomial function of degree equal to 3, and the leading coefficient, and explaining in 1 second what this means, leading coefficient which is equal to also 3. So what does the degree and what does the leading coefficient represent, and why they are important? Well, the degree is the highest exponent. And if you look at this polynomial function, the highest exponent is a 3. Okay? So we have this 3 here, so that's the highest exponent, that's a degree. And then the leading coefficient represents the number in front of the highest degree term. Okay? So let me write it down. So this is the number in front of the highest degree term, which means I need to look at this x cubed, and especially I need to look at the number in front. So if you look at the number in front of the highest degree term, we get the 3. So that's the leading coefficient, okay? So this 3 is the leading coefficient. In this case, they coincide. We have a 3 and 3, but I hope it's clear the difference between a leading coefficient and degree, and I'm going to show some other examples, okay? Alright, so here is another example. And in this example, what we have is 4x squared plus 7x cubed y squared minus negative 6x squared minus 7x cubed y squared minus 4x, and then minus 10x plus 9x squared. So what we want to do is we want to simplify this expression. Now we have a negative here in between the parentheses, so we need to make sure that we use distributive property in order to get rid of those parentheses. We can drop the first ones, so the first one they stay. So the first one, the first expression in parentheses stay the same. There is no change of sign, but then this negative sign will be distributed among those 3 terms in parentheses. So negative times negative is going to make a positive 6x squared, and negative 1 times negative 7 is positive 7x cubed y squared, and negative 1 times negative x is going to be plus 4x. And then this negative sign in front of 10x is going to make a 10x negative 10x, and negative 1 times 9x squared is negative 9x squared. Alright, let's combine like terms. Notice that here we have 2 variables, x and y. So 7x cubed y squared, 7x cubed y squared can be adapted to 14x cubed y squared. And then we have a 4x squared that goes with a 6x squared and can be combined with a negative 9x squared. 4 plus 6 is 10, 10 minus 9 is 1, so we just end up with 1x squared, or just x squared. And then finally we have a 4x minus 10x, which is equal to negative 6x. So this is the simplified expression. So what do you think is the leading coefficient, and what do you think is the degree of this polynomial expression? Before I give you an answer, please think for one moment about a possible answer to this question. Now, in this case, we have 2 variables. Okay, so the leading coefficient we define as to be as the highest degree term. But when we have 2 variables, like in this case x and y, well, x has a power of 3, y has a power of 2, and in this case we are going to adapt the exponent. Okay, so the leading coefficient in this case is going to be equal to 5. So when you have more than 1 variable, adapt the exponent. And this is the highest degree term, this 14x cubed y squared, then the I'm sorry, this 5 is the I made a mistake, this 5 is the degree, not the leading coefficient. Okay, so that's the degree. Okay, so degree is equal to 5, and the leading coefficient, so the leading coefficient is instead the number in front of the highest degree term, which in this case is going to be equal to 14. Okay, so to find the degree of a polynomial function that has more than 1 variable, adapt the exponent, and the leading coefficient is the number in front. Alright, so some other example of adding and subtracting polynomial expressions. So for example, this one, let's assume we have something like 3p squared minus 2p plus 3, and we want to subtract p squared minus 7p plus 7. Again, before I work this problem, try to do this by yourself and then check your understanding with what I'm going to show you. Alright, so to simplify this, we can just drop the first two parentheses, so 3p squared minus 2p plus 3, and then this negative sign is going to make everything with opposite sign for the amount in parentheses, so we have a negative p squared plus 7p minus 7, and at this point we can combine like terms, so 3p squared minus p squared becomes 2p squared, and then this negative 2p can be combined with this 7p to 5p, and then finally we have a numbers, so plus 3 minus 7 is going to add up to negative 4. So what do you think is going to be the degree, and what do you think is going to be the leading coefficient? Well, they actually coincide because the degree is the highest exponent we have, which is a 2, is this number, and the leading coefficient is the number in front of this highest degree term, which is a 2. Okay? So hopefully this makes sense. Here is a question that we can try to answer. If negative x squared plus y squared is subtracted from x squared plus y squared, the difference is okay, so we want to find the difference, okay? So, try to work this problem by yourself, also stop the video, okay? Work this problem by yourself, let's see what you come up with, and then please check with me, okay? Okay, so at this point I hope that you try to work this problem by yourself. So what we need to do? Do we need to write negative x squared plus y squared minus x squared plus y squared, or the opposite? So if I say, for example, if 5 is, so that's an example, okay? If 5 is subtracted from 10, do I need to subtract, so do I need to write 5 minus 10, or do I need to write 10 minus 5? Well, of course I need to write 10 minus 5, which means I need to start with this term. So in this case we have x squared plus y squared, and now I need to subtract negative x squared plus y squared, and so I can drop the first parenthesis and change the sign of the second one because we distribute the negative sign, so negative times negative make it positive x squared, and negative 1 times y squared makes a negative y squared. So y squared and y squared simplify, so we end up with 2x squared with degree that again is going to be equal to 2, and leading coefficient which is equal to 2. That's the degree of the polynomial function, and this is the leading coefficient, okay? I forgot to mention why it's important to talk about degree and leading coefficient. It is important when we are going to talk about the graphing, because degree and leading coefficient really affect the behavior of the polynomial function on a graph. Okay. So I'm going to show you, some other example, and then I'm going to complete this lesson. Okay, so imagine again we have a triangular shape, and what we know is the perimeter of this triangular shape, which is the 7x plus 2y, and we also know two sides. One is 3x minus 5y, and the other side is 2x plus y. And what we want to find is the missing side, the third, so this base for the triangle. Now, one way to proceed is to, at least conceptually, is to start with some numbers, okay, and see what happens with numbers, and try then to use the same process with polynomial expression. So let's assume I tell you that this side has a length equal 3. That's just an example, okay? This side has a length equal to 2, and then I say that the perimeter is, for example, 10. What would you do? Well, you would eventually add up these two sides, 3 plus 2 is equal 5, and then you subtract this from 10. And you will conclude that this missing side is equal 5. Okay? So can we use the same strategy for polynomial expression? Yes, we can. And in order to do that, so instead to add up numbers, we're going to start by adding up these two sides and then subtract from 7x plus 2y. So if I add 2x plus y with 3x minus 5, we end up with 2x plus 3x is 5x, and then y minus 5 is going to stay. And then I'm going to subtract this expression from 7x plus 2y. Oh, I'm sorry, there is a y here, so there will be 2x plus 3x, 5x, so I forgot the y, so this is going to be y minus 5y, which is negative 4y. Okay, and then, so I probably drop the parentheses to add up these two expressions, okay? And then we're going to subtract this from 7x plus 2y, so 7x plus 2y minus, we need to make sure we put this in parentheses, 5x minus 4y. And the negative is going to change the sign of this amount in parentheses, so minus 5x plus 4y, and we can just combine the terms. So 7x minus 5x is 2x, and 2y plus 4y is 6y. Okay? So this is the missing side, which is 2x plus 6y. Now, something we haven't mentioned is this one. If I have a polynomial expression like this one, 2x plus 6y, and I ask you to find the degree and the leading coefficient, then things can be a little bit ambiguous because x and y, they both have a degree equal to 1. So they both can be, so the degree of this polynomial expression for sure is going to be equal to 1. But which one is the leading coefficient? Well, it depends on the application in this case, on the why this application is useful, okay? In this case, it's a very abstract problem. We don't know where are we going to apply this and if we're going to apply this concept. And therefore, you can say that while the degree is for sure 1, the leading coefficient can be ambiguous. If you need this term to be your highest, the 2x to be the highest degree term, then you will say that the leading coefficient is 2. But if you need the 6y to be the highest degree term, you will say that the leading coefficient is 6. So again, it depends if this problem has an application in real life or not. Okay. So in this case, we can say that the leading coefficient is either 2 or 6. So it depends on which one you consider the highest degree term. Okay. Alright, so I'm going to show you one last problem. So if 7x cubed minus 9 x squared y plus xy squared plus y cubed is subtracted from x cubed minus 3x squared y plus 4xy squared plus y cubed. So find the difference. So we already have seen this problem with more simple terms. And again, I invite you guys to try to solve this on your own first, and then check your understanding with what I'm going to show you. Okay, so you should stop the video and try by yourself. Alright, so let me show you can subtract these two polynomial expression. So if this term is subtracted from this term, then I'm going to start from the one on the right hand side of the page, which is x cubed minus 3 x squared y plus 4x y squared plus y cubed, and then minus, so I'm going to subtract the 7x cubed minus 9x squared y plus xy squared plus y cubed. And then, since we have a negative in between, I need to change the sign of this expression on the right side of the page. So we have x cubed minus 3x squared y plus 4xy squared plus y cubed, and this becomes minus 7x cubed plus 9x squared y minus xy squared minus y cubed. So let's combine the terms. X cubed and negative 7x cubed, they are like terms, so this ends up to be negative 6x cubed. Then we have a negative 3x squared y plus 9x squared y. I don't see any other x squared y, so we can combine these two to plus 6x squared y. And then we have a 4xy squared minus xy squared. They combine to 3xy squared. And then y cubed minus y cubed is simplified. So this is the simplified polynomial expression. So it's our difference. There is not an order you need to place these terms. Okay, so you could start with 3xy squared if you want. You could start from 6x squared y, so it doesn't really matter. Okay, you don't need to follow a certain order. So, and again, as I was mentioning in the previous problem, the degree in this case, the degree is fixed, is for sure 3. It doesn't matter which term you pick up. They all have a degree 3 because you have an xy squared or x squared y when you adapt the exponent is 3, and then also if you pick up this x by itself, right, this x cubed is still a degree 3, so the degree for sure is 3. The leading coefficient then is really ambiguous. It can be any of those numbers, so it depends which one you consider the highest degree term. So it can be either 3, or it can be 6, or it can also be negative 6. Okay? Okay, so hopefully it is clear, this explanation. Please let me know if you have any question. Okay, so you can send me messages to my Gmail. If you guys don't know how to get to my to send messages to my Gmail account, here is my email. It's jordan@ga.alif alifisd.net. And I believe if you just type my name, you should be able to see my email address. Okay. You can send me so messages to Schoologies as well. Okay. And again, let me know if you have any question. And I will assign some homework on Alex, and I expect that you guys complete this homework by the due date. Okay, so hope you have a great rest of the day, and again, let me know for any question. I'll see you later. Bye bye.